question, just to make sure we're all clear. So what was the question? It was x to the third minus 4 plus y, right? This was the quiz question. So and they told us x is 2 and y is 5. Okay. So how did that work? How should we have solved that? Well, 85% of you did it just fine. You just take that 2 and you just plug it in there for x, and you take that 5 and you put, that's a y right there. Plug that in for y, just plug them into those slots. And so that's 2 cubed minus 4 plus 5. Once everything's plugged in like that, and then you work that out. What do you do first? That power, huh? 2 to the third. Now, careful, that's not 2 plus 2 plus 2. It's 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And 8 minus 4 is 4, plus 5 is 9. And that was option C, as 85% of you knew. That's good. That's very good. Questions on that one? Is that good? All right. So what's the game plan for today then? So that's our quiz. Normally every day we'll begin and end with a quiz. Now, not on test day. Today's test day, so we won't end with a quiz. We'll end with a test. But on non-test days, we'll normally, begin and end. We always begin and we'll end with a little clicker quiz, one of the questions that we've been working on, something like that, just to help you get ready for the test as well. So anyway, today's game plan, what are we supposed to do? And I'll try to get you a calendar tomorrow. I just turned it in the photocopier yesterday, so I should be able to get you a calendar tomorrow. So we are supposed to cover a bunch of a little more of chapter 2, 2, 3, and 2, 5. Yes, let me write the game plan up for you. So the game plan is today, Thursday, we're going to cover 2, 3, and then 2, 5. We did 2, 4. We're kind of going backwards because 2, 4 was easier. Go back to 2, 3, do 2, 5. And then we'll take our exam, the actual exam, no practice, the real deal today, right? Exam number 1 at the last hour, which would be at 10. It'll be 10 to 11, right? Am I getting our times right? First week, I'm still getting used to how the time works here. Yeah, 10 to 11, that's when we end, right? So that'll be the exam, will be at 10 o'clock. All right, and we did 2.4 yesterday, didn't we? But that was not due, was it, or was it? No. It was not. 2.4 just so we did that yesterday. Yeah. All right. All right. Question, Melissa. Yeah. So depending on how far we get, I'll write it up. Right before we take the test, I'll say, okay, we got this far. I think we'll get through all 3 of these, and all 3 of these we'll have actually 3 sections due tomorrow. Probably. We might not get all the way through 2.5, and then I'll say, okay, just 2.3, 2.4. It's going to be one of those 2 options, depending on how we get. All right, did you guys have fun going over that practice exam thing yesterday? All right, so here we are. That's how do I know that's a multiply? Yeah, those parentheses. Well, we've had parentheses in other problems that don't end up being meaning multiply, right? How do I know these parentheses actually mean that? Yeah, they're right up against the wall, right? Remember, when you're right up against the parenthesis wall, that means multiply. Whereas, if they did it like this, let me change it for a minute. If they did it like this, that would not be multiply anymore, huh? Because now there's something between the walls, right? So if the walls are not right up against, like this one would just be subtract, wouldn't it? It would not be a multiply problem, even though there's parentheses. It would just be a subtract. But we don't have that. We have that. So that's a times. That's a multiply. The 2 walls are right up against each other. Right up against each other. So that's times. All right. So how do we do it? What's the rule for multiplying a couple of letter things?
We add power.
Add powers. We multiply numbers in front, add powers. Exactly. Multiply numbers in front, add powers. So I multiply 2 times minus 5. Negative 10, positive times negative. Yeah, 1 negative is negative, right? Exactly. And then you add the powers, huh? So like the 5 and the 2 will make a to the 7th. And the 4 and the 5 will make b to the 9th. and we're done. Is that good? Easy enough? Getting all these rules down? This will all be stuff on exam 2, which is never far away in the summer. It'll be next Wednesday. All right. So I'm going to flash off of that, if that's okay, on that. Did you guys use that YouTube yesterday, for the practice exam that we went over? Or for whatever, you know. Okay. So minus 9y to the 5th. 7y squared plus 6y minus 6. So take that minus 9y to the 5th and distribute through there. You're doing okay? So boom, boom, boom. That minus 9y to the 5th is going to multiply through. Now remember what happens when we multiply. Out front numbers multiply, powers add, right? Out front numbers multiply, powers add. So minus 9y to the 5th times 7y to the 2nd. What's going to happen? Use your calculator if you're rusty on some of those times tables. 7 times 9, 63, and it's negative, huh? Because one negative is negative, two negatives would be positive. And then what do the powers do? They add to be 7. Good for the first one? Now the second one. The minus 9y to the 5th goes to the 6y. Out front numbers multiply. 6 times 9 is 54, so it'd be minus 54. And the powers are going to add. You got the invisible 1. You're getting used to remembering him, right? For the test today. And then, lastly, minus 9y to the 5th times minus 6. It's going to be positive. Good. Yeah, did you notice that? Because that's two negatives getting together, huh? Everybody see that? Let me write it more clearly. Remember the baby thing. So this is his baby. That minus is on that 6, huh? So this minus is on this 6, and this minus is clearly on that 9. So those are two negative things multiplying. And two negatives multiplied become a positive, don't they? So that's positive. 6 times 9 is 54. Y to the 5th. Like that. And that's as far as we can go, because those are unlike terms. I cannot add them or subtract them. Adding, subtracting is picky, only like terms. I stop right there.
Why did you put the y at the last one?
Yeah, I was just going in order. In other words, I was just taking the one in the front and multiplying the first, and that became first. Multiplying the second, and that became second. Multiplying the third, and that became third.
Okay.
Just kept it in that order. Other questions? Any questions on that? Good. See how the signs all changed? Did you notice that? Whenever you have a negative here in the front, negative, it ends up changing all the signs. This positive became negative, positive became negative, negative became positive, huh? All three signs in the front changed. So that's what it does when you multiply by a negative. Changes everybody's signs. Good? It's all making sense? Multiply numbers in the front, add the powers. All right, so we have 4xy to the 4th parentheses 2xy squared minus 3xy plus 5x. Okay, so same thing, multiplying all three of those because it's right up against the parenthesis wall. That means multiply. So multiply the numbers in the front, add the powers. Good. I'm going to crank through that one. You ready? So boom, boom, boom. 3 multiplications. So here we go. 4xy to the 4th times 2xy squared. What's going to happen? Out front numbers multiply. 2 times 4 is 8. And then the powers add, right? Yeah, so the invisible 1, the x squared. And then the y, 4 and 2 makes 6. Good for the first one? You see what happened there? Out front numbers multiplied and the powers added. And now for the middle one. So we're going to have the 4xy to the 4th to the middle one. That'll be what? Minus 12. 4 times negative 3. Positive times negative is negative. And then the invisible powers add. So 1 powers. X squared y to the 5th. Like that. Add up those powers.
Where did after the 8 x squared, where did the 2 come from, the x squared?
Oh, because the 1 and the 1.
Oh, okay, so they're separate. The x and the y is separate from, the x are separate, the x and the y?
Yeah, so we do the x's separately. Yeah, right. So we look at the 2 x's separately. You're right. You're totally right. Look at the 2 x's separately and add those. 1 and 1 is 2, and then the 2 y's separately. 4 and 2 make 6. Yeah, I see what you're saying. You're totally right. Oh, I see. Were you meaning like when you have xy squared, you were thinking that 2 was for both of them?
Yeah.
Oh, no. That would only be with parentheses. If there was parentheses, then that 2 would be for both of them. Yeah, no, if it's just written like this, the 2 is only on the y, and the x has his own invisible 1. Good question. I see. Yeah. Yep. Good. Good. And then the third one here, plus 4 times 5 is 20. Add the invisible 1 powers again. So x to the 1 is x2, y to the 4. And there we are. We're done. Right there. Questions on that one? No troubles? It's all good? Getting the hang of these? This will all be exam 2. We'll take the practice exam on Tuesday. That's why we come back from our Memorial Day holiday that I forgot about when I made the original calendar. I said practice exam. So practice exam Tuesday, real exam Wednesday. Yeah. Act and multiply. This is where it's always challenging, where they mix everything together. Okay, so we've got minus 5 times 5y minus 9 plus 3 times 4y plus 9. Okay. So there's the deal. So here we have 2 separate problems, right? Added together. Let's try that one. Take the minus 5 and go boom, boom, first off. So the minus 5 is just multiplying through the first parenthesis, right? And then the plus 3 will multiply through the second parenthesis. Good to there so far. Everybody see how the signs work there? So the minus 5 times plus 5y made negative 25y, and then negative times negative with the 5 and the 9 made plus 45. Good so far for the first one?
Yes.
Now for the second one, plus 3 times 4 is 12y, and plus 3 times 9, 27. Now we have one more step to do this time, but is everybody okay to there? Questions to there? Everybody see how I got those? Now, why do I say we have another step this time? Well, this was multiplying because we had parentheses, right? Now we have no parentheses, so I'm in adding, subtracting mode. Right, but so what? Well, now I can actually do it because we have like terms, don't we? Remember, adding, subtracting is picky all the way through the next 3 courses, this course and 2 more. Adding, subtracting, anything in algebra is picky. Only like terms, but I have like terms. Those 2 will be like terms, and so will the plain numbers, huh? That makes sense? You can't, whereas look back at the last one. See how all these were different? None of them had the exact same letter pattern. They all had different letter patterns. That's why I didn't add them. That's why there was nothing more to do after the first step. These were just one-steppers because there was nothing you could add or subtract on all the previous problems we've done today. There were never like terms. Like terms mean same letter pattern, right? There were never like terms. We just multiplied and done because I can't add them or subtract them. They're not like terms. They're different letter patterns, all of them, right? But now on this one, for the first time today, I go, oh, this guy and this guy, they're the same exact letter pattern. They can add. They're like terms. So now I can do the adding. How do you do that? What do you do when you add? You just do the numbers in the front. You don't mess with the letters or the powers at all, right? That's the difference. So numbers in the front only, no powers. Just numbers in the front only. So negative 25 and plus 12 is negative 13y. You don't make it y squared or you don't mess with the letter pattern at all.
How come?
Well, that's what it really is. So, for example, like what if let me give you real life. What if I said I got 2 apples, and then later I grabbed 3 apples? What do I got? 5 apples, not 5 apples squared. No, the letter is just like, it's just representing something, right? So I could do apples. So that's why, for example, 2x and 3x is 5x. It's not 5x squared. That's what I'm saying. You don't mess with the letter. You don't make it squared or anything. You just 2 apples and 3 apples is 5 apples. 2 x's and 3 x's is 5 x's.
Is that only in addition and subtraction?
That's only in addition and subtraction, because we add powers when we multiply, huh? Exactly right. Has everybody seen that difference? So when you multiply letters, you do add the powers. But when you add, subtract letter stuff, you only do the numbers in the front. You don't mess with powers, because that's real life. Like 2 apples and 3 apples is 5 apples, not apples squared or something weird like that. So when I do the minus 25y and the plus 12y, it's just minus 13y. Don't make it y squared or anything like that. Question?
Yeah, I was just
Alex.
wondering if it was helpful to think of it as 25 y's, but they're adding instead of multiplying.
Yeah, exactly. It's 25 y's being added and subtracted and stuff. Yep, that's right. So now, and then the plain numbers, right? 45 and 27, what is that? 72? And there's our final answer. So that one is harder because we had the multiplying step, and we got to think the multiplying rules, and then we got to totally shift gears in our mind and change to adding, subtracting rules, which are different. Adding, subtracting, only the numbers in the front, don't mess with the powers, huh? And only like terms, picky, for adding, subtracting, huh?
So if that 4y had a 3 on it, then we would add, in the multiplication part, then we would add powers.
So if this had a 3 here,
Yeah.
Okay.
Multiplying, then we would add the powers.
add powers on same letters. I don't have another y, though, up there.
That's not a y right there, 5y?
Oh, yeah, well, these guys are multiplying with each other, and these guys are multiplying with each other. So if I had like a 3y here, say this was a y, 3y, then this 1 and this 1 would have made 12y squared.
Oh.
Does that make sense?
And then adding it would just, and adding that onto that would, it just would have stayed the same?
Yeah, so I would have got to here and got 12y squared, and then this guy could not add to this guy because now their letter patterns would not match. They would just stay separate. Only the two numbers would add. These guys would just sit there doing nothing. The two numbers would add, and we'd be done. Because then they could not add each other because they would be different letter patterns. They're apples and oranges, so to speak, now. Does that make sense? Good questions. Everybody seeing those rules? So when it comes to adding and subtracting, it's all picky. It's only apples with apples, not different. So yeah, that would make it different. So I got to get rid of this. What was it originally? It was just 3 and 4y plus 9, and then no 2 power there. Yeah, good. All right, let's keep moving. All right. There it is. So 3, 8x squared minus 4x plus 21 plus 3, 6x squared plus 8x minus 58. All right, so try that one. So the 3's in the front want to multiply, right? Let them multiply through it's water in front of the floodgate. The walls are going to come down, the water's going in. Doing okay. So 3 times 8, 20, 4x squared, 12x, 63. Good for the first 3 there. And then the back 3. Is that 18x squared, 24x, 150, 174. Is that what it is? Use calculator there. Good to there. That okay to there? Now, multiplying's over, right? So this was the multiplying step. We had the parentheses. Now we're in adding, subtracting. So we got to put on a new set of rules in our mind, right? A new set of rules for adding and subtracting. And what are those rules? Only like terms. And then only the numbers in the front. Don't mess around with powers, huh? Right on that? So 24x squared and 18x squared. Is that what that is? 42? Yeah, 42x squared. And I don't mess with the powers, huh? I don't make that x to the 4th or anything like that. Remember, it's just apples with apples. Just 24 apples and 18 apples, 42 apples. Just keep the letter the same. Good so far? And then minus 12x and plus 24x, they're like terms. They will add together. It's really subtraction, huh? 24 minus 12 is 12. Positive 12, right? Everybody see why that's positive? Because it's a gain of 24 and a loss of 12. 24 minus 12 is plus 12. Good. And lastly, the 63 and the minus 1. Just use your calculator. What was that? Minus 111?
Yes.
And we're done. There's our answer. Good? On that, questions I can answer? All right. Okay, so 4b plus 2g, 4b minus 2g. All right, so we're supposed to multiply those out. So remember like we did yesterday? So that's the FOIL thing, right? The first, it's two parentheses right up against each other, so it's multiply. And so you're going to take, like we did these yesterday, so that 4b is going to go boom and a boom, like that. And when he's done, then the 2g is going to go boom and boom. First to both, second to both. Remember how that works? And as you multiply, out front numbers multiply, invisible 1 powers add. Right? Okay, so as we multiply, out front numbers multiply, powers add. So 4b times 4b, that's 16b squared because the invisible 1 power is added. Good so far. Out front numbers multiply, powers add. Minus, remember this minus, remember the baby thing, that minus is on that too, huh? And remember their signs are on whoever they're in front of. And that plus is on that too. So here we go. 4b times minus 2g is minus 8bg. And then this one's done. That 4b went to both. And now the 2g is going to go to both. Everybody good so far? So now it's this guy's turn. He's going to go boom, and then he's going to go boom. So 2g times 4b is plus 8bg. And then 2g is minus, right, because it's positive times negative. Positive 2 times negative 2 is minus 4g squared, because the invisible 1 powers on the g's add. Is that good? Remember all those little rules? And then these guys cancel, don't they? They're the same exact thing, and they just drop out. So all we have then is 16b squared minus 4g squared. And we're done. Questions on that? How many got that? Did you get that one? Is that one good? Okay, about half, huh?
I missed the square.
On the G?
Yes.
Yeah, it's easy to forget that little stuff. Excuse me. Yeah, the little invisible 1 powers, right?
Yes.
Yeah. All right, just keep practicing. There's. All right, so 5a minus 1, parentheses, 6a minus 3. So don't forget the invisible 1 powers. All right, so that 5a is going to go to both. So as we go, out front numbers multiply, powers add. So 5a times 6a is 30a squared. Good. The invisible 1 powers added there. Minus 15a. He's done. He went to both. Good so far. And now the minus 1 is going to go to both. Minus 6a plus 3, because negative 1 times negative 3, 2 negatives, multiply to be positive. Good to there so far. So that was the multiplying step, right? We had parentheses and we multiplied. Now we're on the adding, subtracting, so different set of rules. Now we're thinking about only like terms. Just like terms. And only numbers in the front, right? No powers. So that'd be these two, right? Those are like terms. Those are both the same letter pattern, aren't they? So I just do the numbers. So bring down the 30a squared, bring down the plus 3 in the back. They're not doing anything. But then in the middle, those two combine. Minus 15a and minus 6a is minus 21a. And we're done. Right? Is that good? It was like if you lose $15 and you lose $6, you lost $21, right? Negative and a negative. Make a bigger negative when it comes to adding, subtracting. 2 negatives don't make a positive there because I'm not multiplying. I'm adding, subtracting. And there it is. Good? We did a bunch of those yesterday. Those are probably easier for you than the earlier ones, huh? Because you're used to those from yesterday. Questions I can answer on that? All's well? All right. Okay, so we're going to have a minus 4, a squared plus 4a plus 16. All right, so same thing. Try that one. So the first one goes to all 3, and the second one goes to all 3. Try that one. It's a longer one. I'll give us just a little bit longer to. Let's see. So this first off, so it's about ones in the first parenthesis is going to visit all the ones in the other parenthesis. I think it's helpful if you're having any trouble. Draw those arcs in there. Draw those actual arrows. I'd encourage you to really follow what I'm doing if you're having any trouble at all. So a times a squared. So that a is going to visit all 3 of these, right? And every time it hits one of them, what's going to happen? Out front numbers multiply, powers add. So this has a 1 power, invisible 1, with the 2 power, so that'll make a to the 3rd. Good there. And then the a to the 1 is going to hit, it's going to travel and hit the second one. And this has a 4a to the 1. So that's going to be plus 4a to the 2. The 1 powers add. We good with that? Plus, and then this a hits the 16. 16a. He's done. He's went to all 3. Does everybody see how I got those 3? I was just taking the a there, and I was just hitting it with an a to the 1. And so that adds 1 to the power, and then just lands next to the 16. Does it? That good? All right, so now that he's done, now I take the minus 4. And that minus, that is on him. That's his baby. He's going to take that minus with him as he travels, right? All right, you should take your baby with you when you travel. So that negative is on the 4 wherever he may go. So that negative 4 is going to go boom, boom, boom. It's going to hit all 3 of those. I'm going to take that negative 4 and I'm gonna go boom, 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 and hit all three of those, right? And every time it hits, it'll multiply the number in the front, right? So negative 4a squared. It just went to the front right here. And then now it's going to hit right here. Negative 4 times positive 4, negative 16. Whoop, that's not very well written. Minus 16a. Good so far? Everybody see what happened there? And finally, minus 64. That came from negative 4 times 16. Use your calculator. Minus 64. See how those black 3 came about? Right, that was minus 4 going boom, 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 hitting all three of those. It made all of them negative, didn't it? On that. Is that good? Now, we got a bunch of canceling happening. Right now, now's the adding, subtracting step. We already did the multiplying step with the parentheses. Parentheses are gone now. So now we're in adding, subtracting mode. 4a squared, cancel, 16a's. Cancel. All we have left, a to the third minus 64. Like that. Questions I can answer. Is that making sense? If you're having trouble on these, things are picking up a little bit in difficulty now. Lots more letters and all that kind of stuff. If you're having trouble, you know, that's why we have Roberto. Where's ours up here? Yeah, Roberto. He's there after class. You know, spend some time with Roberto. He'll be, and you just do your homework in there too. It's a great place just to do your homework, right? Just after class, go grab lunch after class. That's what I do. Grab lunch after class, and then head over to the tutoring center and get your homework done. A couple hours. Roberto's there. You have computers there. You can work on your stuff right there. Great thing to do. Get the help you need to make it through math class. Good? All right. Okay. So, let's see. What do we have here? We have y minus 7 minus 6y squared plus 8y plus 4. All right, so same kind of thing. They're going to take turns. First off the y, I encourage you to draw these arrows. That y is going to go boom, 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 and hit those three, right? 4 hours together. Making good use of this time. So you come out knowing some math. All right, so the y is going to go first, and he's going to go boom, 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 right? It's like visiting your neighbors or something, right? The first one is going to visit the other three, and then the second one's going to visit the other three, right? So first off, this y is going to go visiting. Boom, boom, boom. He's going to hit those three. And when he does, powers are going to add, huh? He's got an invisible one, and the one in the middle has an invisible one. So what happens? So minus 6y to the third. Powers added, right? The invisible one added to the 2. Plus 8y squared. The 2 invisible ones added. Plus 4y. He's done. He went to wall 3. First to wall 3. Okay, now the minus 7. This is his minus sign. That's his baby. He's going to take the negative with him. It's going to go boom, boom, boom. He's going to hit all three, right? So that minus 7 is going to go visiting. Boom, boom, boom. It's going to hit all three. So negative 7 times negative 6y squared is positive. Use your calculator if you're rusty on the times tables. 6 times 7, 42. Positive, though. Did everybody see why that's positive? That's the easiest place to mess up right there. 2 negatives multiply to be positive, huh? Right there. And then the negative 7 goes here. That'd be minus 56y. Like that. And then negative 7 times plus 4, negative 28. Is that good? So far. Now the multiplying's over, right? No more parentheses. Right? That was the multiplying step. Now I'm on the adding, subtracting, which means a different set of rules. A whole different set of rules. What rules? Not everything, but only like terms. Right? Like terms and no powers. You don't mess with powers, huh? So for adding, subtracting, it's real picky. It's like only like terms, not everything, only like terms. And we don't mess with powers. So, this guy, does he have anybody like him? No. He's his own kind of thing. He's separate. So you just keep him by himself. He doesn't combine with anything. He has no like terms. Okay, how about the 8y squared? Is there a like term for him to combine with? The plus 42y squared. They have the same letter pattern, like terms, right? So you add them up. 42 and 8, 50 y squared. Good? And now, how about 4y and minus 56y? They're like terms. They will subtract. 4 minus 56? Minus 52y. Good to there. And what comes last? The minus 28 just pops down. And there we go. There's our answer. How we doing? How many got that? Did you get that right? Okay, looks like 2/3 of you. Questions I can answer. Is it getting easier? Less painful? More smooth? Yeah.
On the 42y, at first I got cube.
What's that?
On the 42y,
Yeah.
at first I got cube, but you're supposed to just add them on.
Right. Oh, I see what you're saying. Yeah, just add the powers. Oh, yeah. I'm sorry. It comes from the minus 7, which has no y at all, and the minus 6. So it's just the y squared. There is no other y. This doesn't have a y to the 1. It doesn't have a y at all.
So you only do the exponents when they have a
Letter.
variable?
Yeah, it's only when there is an x or is a y that there's a 1 on the x or y. If there's no x or y, then there's no powers at all. Yeah, you're right on. Good. Good, Stephen. Good. Other questions on that? That good? All right. Yes. All right. So v squared plus v minus 1, v squared plus 5v minus 7. All right, so let me just give a little help. It's going to be 9 multiplications altogether. How do I know that? The first v squared is going to go boom, boom, boom. He's going to go to all 3. And then when he's done, the second guy is going to go to all 3, right? The plus v in the middle here is going to go boom, boom, boom. And then when he's done the minus 1, it's going to go, now it's my turn. Boom, boom, boom. Right? So they're all going to visit all 3 in the other parenthesis. 9 multiplications. You know the rules. Add the invisible powers when you got them. Yeah, they do. Good, great. Right, it's just 2, it's not 3. Yeah, you're totally good, right. What sign do you lose? What sign in the middle? What sign? Yeah, because the thing is perfect. towards that? Yeah, so remember, whenever they get together, it's two minuses x plus, it's just one minus x minus. So. There's a little mistake on this one. This one. You should do good otherwise. Good. A lot of terms. You guys getting all those terms? 9 of them. Give you just another minute here. Matter. Even though they wrote it vertical, you don't have to do it that way. It'll work either way. Yeah, I'm probably just going to write these sideways, but then the answers I'm going to put vertical. But if you want, you can just do the whole thing. Yeah, I think I would just do it normal. Do it normal, but write your answers vertical. Do you know what I'm saying? Like, take the 3a, let him have his turn. 3a squared plus 15a. And then when you do the next one, the minus 5, bring him down. Minus 5a minus 25. So I'm kind of doing this one for you, just to show you what I mean by vertical, right? So put the first one on the first line, the second one on the second line. You see how I did that?
So when they say find the product vertically, the first way they have it is pretty much formatted the same way.
Yeah, it's the same thing. Yeah, you can do it vertical or sideways. I think it's easier to write it sideways but do the answer vertical. But whatever works for you is fine.
We're only multiplying them because they said product.
Yeah,
Right? Because
exactly.
there's no symbol on the equation.
Well said, well said. That's right, because of the word product. Exactly.
If we had encountered that and they didn't say product, what would be?
You couldn't know. Yeah, because there's no symbol, they got to put a word. If they don't put a word or a symbol, then we're lost. Yeah. Is that good? Everybody see how I'm getting that? And then we can just do it vertical. So then this is just 3a squared. This is what? 10a. And that's minus 25. And there we go. Good on that. Questions on that? All right, let's try another one of them vertical. Okay, so, yeah, how are we going to do this? Would you guys want me to show you one where it's vertical from the beginning? I mean, I could do that. I hesitate to give you too many different things. That can be confusing. You know, when I'm doing a different way every time, it's hard to follow. But maybe if it's beneficial to you, I'll do one vertically. So what they mean by vertically is like how you learn to multiply. You know, when you're a kid and you're multiplying by hand. That's pretty much what they're talking about. So in other words, where do you start? You start with a 9, huh? And what's he going to do? He's going to go there, there, and there. It's the same thing we're doing when we have the parentheses and we distribute. It's just being done vertically instead of sideways. But it might be easier. I don't know. Whatever you like. So 9 times x squared is 9x squared. 9 times minus 2x is minus 18x. 9 times 2 is 18. He's done. He went to all three. See what I did there? I just took that 9 and went boom, boom, boom. On that.
Shouldn't you start with the x instead of 9?
Remember how when you multiply with numbers? Yeah. 27 times 13, where do you start? This guy. Start with the guy on the right. Remember that? Just like multiplying?
So if we put it horizontal, you would put 9 plus x.
No. So if you started horizontal, you'd put the x plus 9 in the front. X would go first.
Oh, okay, that.
Get the same thing. Get those same three things. That good? Yeah.
Just a comment, I feel like this would be important to know, because I feel like it's like one of those things that's gonna trip me up on a test someday.
Yeah.
I'm gonna be like, what the heck is that?
Yeah. No, this is super important. Yeah, we're gonna be multiplying forever.
I'm still having issues with x plus 9.
Yeah.
Why you put it on the right side instead of the left? I mean, on the left side instead of the right. Because if you go the way that we did it before,
Yeah.
it will be parentheses x squared minus 2x plus 2. And then in different, right next to it will be x plus 9.
Okay.
So you will go x squared times x.
Okay, yeah, let me pick it up right there. So you know that when you multiply two numbers, the order doesn't matter. 6 either way, right? Same thing with these parentheses. You can swap the whole parentheses anytime you want. It's going to come out the same in the end. So whether I put it left or right, in the end doesn't matter. Because x's are just numbers I don't currently know. So if you can switch numbers, you can switch x's.
Right.
It's all the same rules. Yeah.
I think it's a convenience thing because if you put x plus 9 on the left side,
Uh-huh.
you have 2 steps to do, whereas if you flip them and you put the x squared minus 2x plus 2, you'll have 3 steps.
I think so too. It's harder to put the bigger one in the front, I think. I mean, in the end, it's kind of the same, but it seems harder to me too. Yeah. So whatever way you like, yeah, whatever's made is more convenient, but I feel that way too. So let me finish this one up. So I've only done the 9 right now, right? Now it's the x's turn to do what? To go boom, boom, boom. X times x squared, x cubed. Why did he put him in the front? Because he's a higher power. X to the 1 added to x to the 2. Right? This is the x cubed row, x squared, x to the first, no x. See the lineup? Highest power down to lowest. Third power, second power, first. So then he goes here, x1 is minus 2x2. Then he goes here, plus 2x. Do you see that? So you could do it in any order. If you wanted to start with this x first and then do the 9, that's okay also. The order none of the order matters. You can do this stuff. You can swap the top and the bottom, left and right, this one first, that one second, whatever. Any order is fine as long as everybody multiplies everybody. It doesn't matter what order you do it in. Whatever's easiest for you. Now, we've got to finish them up, right? So this will be x cubed, and then 9 minus 2, plus 7, minus 18 plus 2, and bring down the 18. We're done. Is that better or worse?
It's different.
Different, yeah.
I know, I'm sure it's not a thrill that I keep changing the game plan here.
And it's actually easier, but getting in the
Used to
habit,
it. We haven't done 10 of them that way.
It's different, but
Yeah.
it's convenient, I guess, when you look at it.
Yeah, I kind of think that way too. It's probably easier to do it this way, but maybe we should have been doing that from the beginning. Yeah. Yeah, you know. We should have played for the bonus class. No, I'm just kidding. All right. So let's try. How about we try one more of these vertical ones? And you can do it whichever way you're comfortable with. All right.
Put it like 5 lessons later.
Here it is all of a sudden. All right. So let's try that one. So 3x squared plus 8x plus 6. 2x plus 3. Let's do it vertical. You know, how about we just start with the 2x? Maybe I was confusing you by starting with the 3. Whatever, you can start with either one. Doesn't matter. Just start with this one and go boom, boom, boom. Go to all 3. Write your answers down here. And then when you're done, then let the 3 have his turn. And try to line up the powers vertically when you write down the answers for the multiplication. So give that a try.
Isn't that kind of contrary to regular multiplication rules? If they were all digits,
You can actually do that with regulars as well, as long as you remember to put a 0 on the 1. Yeah, it doesn't matter when we're there either. I know the kids never do it that way, but it's true.
I've never really shown that way.
Yeah.
That's interesting.
Yeah, there's actually a whole other systems of ways to multiply.
Wow.
Other countries throughout history they've done.
do it like this? Do I do it that way or do I do it like?
Yeah, you want the highest powers on here, so I would start with the front here. I would go front. Yeah, I'm kind of learning with you. I don't normally do it this way, but I know it might be easy. Yeah, I would start, let's do front with front. Start with the front first. Yeah, it'll be easier because then it'll be the highest powers. Even though it's true you can do it in any order, I think it'll be hard if you do it backwards because then you get the low powers and you'll be confused, I think. So any order is technically fine, but I think it'd be easiest to start. So I'm going to break my rule. Last time I started with 3. I'm going to start with the one in the front. I just think that'd be easier when it comes to letters. Start with the highest letters first. So do the front with the front first. Start there. Be a little easier. Well, okay, see how that's 3x squared up there? Yeah, I can show you somewhere. Yeah, let me watch it. I'll watch it. You're saying that.
Just so you can see that.
There we go. So we'll have it right. There we go. All right. No, don't start there. Remember what I was saying? Start with front and front. 2x and go to the front. Don't start with that. Okay. Yeah, it'll work. You're right. Good. Whoop. Yeah.
Now we're all gonna come out with different answers.
Excellent. Good. Very good. Now just add them vertically. That's perfect.
Okay, so Adam.
And just the numbers in the front.
Yeah,
Don't
no,
nothing
yeah,
else.
but like normally we would subtract it, correct?
No, this is always add.
Yeah.
You're thinking about long division.
Okay, thank you.
There it is, long division you subtract. No, these are add.
Okay.
Yeah.
Thank you.
All right. Okay, so, all right. Having said all that I've said, let me change my mind yet again one more time. I mean, you can do whatever you want, but I keep changing my mind what would be easiest. Whoops. What would be easiest is if I don't keep changing my mind. But, so do whatever way you want, but maybe it is more natural for you guys to start with a 3. Is that more natural? Because you're just used to that from when you were a kid and you had to multiply a bunch of numbers together? So just take that 3 and go boom, boom, boom. That'd be fine. Like I said, the order doesn't matter. Get 18, 24x, 9x squared, like that. That easiest? You can do that if you want. Start on the right side, I guess. I should just not keep changing the plan. So start on the right side, multiply all 3 like that. And then when that one's done, now I'm going to do the 2x. It's his turn, right? And go boom, boom, boom. So 2x times 6. 12x, and that's going to go here in the regular x column, huh? 2x times 8x. 1 power. So it's going to be 16x squared. And 2x times 3x squared in the front here. 6x to the 3rd because the 1 power and the 2 power add. See that? And now we just add them up. Just add them vertically. So this will be 6x cubed. This will be 25x squared. This will be, what, 36x. And this is 18. And we're done. Is that good? One way or the other, did you get there?
Yeah.
So maybe it's easiest that way, just to start on the right side. Questions on that? How many got that? How many got that answer right? How are we doing? Let's see how many. Good. Okay, so great majority. Just wondering how many more to do. See how you're all doing. We got 2 more. It's probably worth our time to do those. Okay, so do you happen to remember the area formula for a rectangle like that? Yeah, it's just one side times the other. So you just take one of these times the other, just W times 5W. This wants you to take one side. Doesn't matter what order. You put the 5W in the front, then the W, whatever. And then how do you multiply? After all our big messy multiplications, this should be an easy one. How do you multiply? It's almost too simple. What's the rule there?
Add the exponents.
Just add the invisible 1 powers, right? 5W to the second, done. Good? That's all they want on that one. Just multiply those 2 sides together. And then, finally, so we're supposed to multiply one side times the other. Why don't we do it vertical? Since we've been getting used to that, maybe that'll be easier. So it doesn't matter which one you put in the top. I'll just put 3x minus 1 on the top, x plus 6 in the bottom. You can do it the other way. Doesn't matter at all. Like that. And so let's just do it vertical. So remember, so start with the 6 on the right side and go boom and boom, right? See if you can carry that out. We're supposed to times them, right? Good, so we get minus 6 and 18x. 18x minus 6. Good for the first 2. And now it's the x's turn. He's going to go there and there, right? Is that making sense? So x times minus 1, minus 1x. Put it under the other x. And x times 3x, 3x squared. Is that good? Excuse me. Excuse me. And now we just add them up. Everybody okay how I'm getting those?
Yeah.
So I just did it, vertically. Just did the 6 to both, and the x to both. Write them down, line them up.
Do it vertically, or just do it like horizontally?
You can do it horizontally.
Okay.
Yeah. You prefer?
Yeah.
So then 3x squared, these two make 17x minus x. So there's our 3 terms. That good on that? If I confused you more now by changing gears 3 times here, we good? You still able to do that okay?
Yeah.
No comment. Gee, this reminds me of, did you see on the internet a couple days ago, what was it, that game Go or something? And the Chinese guy, the national champion, was battling the Google computer. I guess Google wrote a program to battle. Anyway, he's the world champion. He's 18-year-old kid, 19-year-old kid, was battling. Did you see that? And he was boasting beforehand that he would beat it. He's always beat it in the past, but the program has improved over the last year. He beat it last year, and it beat him yesterday or 2 days ago. And the part that cracks me up is it's big. I guess it's big in China. This game called Go. I never heard of it. I don't know what it is, but anyway, some complex chessboard kind of game thing. Anyway,
China or Korea?
It was China. Yeah, he beat the Korean champion 2 years ago. The Korean guy's number 2. This Chinese guy is the number 1 in the world, and he beat the Google program, the computer program, a year ago. Pretty easy, but I guess the program is, they had the program play itself for a year, and it learned more, I guess. It's about artificial intelligence and all that. Anyway, the part that cracked me up was they were broadcasting this live. This is big in China, like some giant sport for us, like we love baseball, soccer, football, whatever. Anyway, they were like nationally watching it, right? Because they were sure he was going to beat the computer. And then about halfway through, it became clear that the computer was going to win. And they cut the broadcast to China's mainland. I think it's so funny the way the Chinese control the information, you know, the internet. If there's ever any dishonor come, they just pull the plug. Nothing to see here. Nothing to see here. I think that's so funny. What's that?
Yeah, just tell them we still won.
Yeah. We don't know what happened. So funny. That's right.